Hi, in this video I'm going to discuss about a very popular machine learning algorithm known as the nearest neighbor machine learning algorithm. It is a classification algorithm. It can also be used for regression problem, but we will see only the classification aspect of nearest neighbor algorithm. So we call that as nearest neighbor classifiers. So what's the basic idea behind the nearest neighbor classifier? Well, it goes like that. If it walks like a duck, then it is probably a duck. That means uh, here is the picture and the code goes like this. The picture is that we have been given a picture and it looks like a duck, but we do not actually know whether it is actually a duck or not. So this is a training set. We have got different birds, and we'll just have to match what is the closest this picture is with the given pictures. Okay, and so all we need to do here is to measure the distance. Okay, how close this picture is with another picture. The closest the picture is, the more likely or the more probable the picture is similar to a given picture. So this is our training set. Okay, so this is a given training set, and all we need to do is compute distance, and you will find that one that has least distance in terms of the behavior of this picture or the behavior of the attributes of it, this bird, we will match that to this given one. So this is a test record, and we are trying to match it to some one record from the training one. So that's exactly what we'll see in a nearest neighbor method of classifying a data point. So here is another example. So they have got different circles, and the circles are marked in two different colors, and we have a test set. So this test one is the in the black, with this black circles. So we need to know, and this is a totally new one. Is it which color is it? Is it of this one or this one? Okay, there we get the two different colors. So how do we get to know? So we get to know using nearest neighbor method. So we take a majority vote. So majority vote within k nearest neighbors. So we take k nearest neighbor. K could be anything. It could be 1, 2, 3, or it could be even more than 3. So we'll take the k nearest neighbor to this test or the new circle, and we'll take a majority count. Okay, so if you take these three, and we suppose these three are the closest circle to this the new circle, which is the black one, and k here is 3. So what is the majority? Well, the majority is that we have got uh, we have got okay 3 grain. Okay, maybe it is considering another one. Maybe we can consider this one. Okay, if k is 4, we have got 3 greens and just 1 brown. That means the new circle is just a green circle, right? If k is 3, we have got this one and this one, 2 circles which are green, and just one which is brown. So the majority is that it is a green. Hence we conclude that it is a green circle. So the new circle or the given one is a green. So formula to find it out is calculate the mean, and k could be any number, and we'll see how to choose the best k or the optimal k. K could be anything, by the way. It could start from 1 to n. N could be of any number. So it's not good to take just very small k or very large k. So we'll see what is the optimal k. So the estimated value of x is the new one, is given by, just take y's means give a subset of the training set, take the majority count, the one that is is major or is appearing maximum times in your given subset, is the one to be chosen for the new data, or the new or the unknown data. Okay, so unknown data is just the test data for you. Alright, so this is the unknown record, and you will have, not just one unknown record, it could have many. So it requires three things: a set of stored records, which is your training set. Of course, technically speaking, it's a training set. Distance matrix to compute distance between records. So we should be able to compute the distance between what? Between you given a new data, the new data point. This is the new data point. That's what we have marked it in red, and the corresponding near values, right? Near values. Okay. Alright, and the third thing is the value of k, the number of nearest neighbors to retrieve. That means you also need to know what exactly should be the value of k. It should be 3, 4. So that is another important thing that one should find it out, and we'll see how do we come up with an optimal k. So to classify an unknown record, we need to compute the distance to the other training records. So we just compute the distance using some sort of a distance formula. It could be a Euclid formula or some other formula. Identify k nearest neighbor, which is of course very important. Use class levels of nearest neighbors to determine the class levels of unknown record. In case it is a classification problem, of course, we need to take the maximum count. If it is a regression problem, we just need to take the average of the maximum counts. Okay, so that's essentially a difference between using a nearest neighbor for classification and for regression. So for classification, take the maximum of the number of data points of a particular category within that nearest neighbor subset. So here in this case, when you take the circle, we see that there is only plus signs. There is no minus sign, right? It's only plus. It's only positive signs. There is no negative. Hence, the new data point is nothing but a plus. Okay. So if you take some data point here, and let's say k equal to 4, and take the nearest neighbor over here, you will find the data point is closer to the negative signs, right? And that's a negative. That's what we conclude. So the estimation is very simple. It's just very crude way of, so to say, computing or classifying a new data with a given training data. Okay, so there could be several numbers that can be associated with k. It can be 1, 2, 3 or more. So here is an example of just k equal to 1. Okay, this is a given, this is a new data, and the given data is just negative and positive, and we just taken the most closest one, or the first one, which is the most closest one, and it's a negative one. Now we conclude that x is negative. Now just take 2. You cannot conclude because there is just one negative and one positive. Okay. Now you take 3, k equal to 3. We've got 2 positives and just 1 negative. That means it turns out that x is positive. So when k equal to 1, we concluded that x is negative, whereas when k equal to 3, we concluded that x is positive. Now that's a very drawback of using a nearest neighbor, that if you change k, your answer actually is changing. So what is the most appropriate k that you should take? So the idea is that you should take a number that is that gives you the best possible answer, and getting that threshold value is the key. So what you need to do here is that compute distance between 2 points. How do you compute distance between 2 points? Well, if you familiar with the high school algebra, computing distance between 2 points with in a plane x1 y1, let's say this is x2 y2, is nothing but x2 minus x1 square plus y2 minus y1 square, and then just square root of that. So if pi is a data point, qi is another data point, just take the difference. Difference could be the coordinates or just any number. It could be any quantity, a length, breadth, height, weight, or anything, any measurable quantity. Take the summation of that, square of the summation, and take the square root, and you find the distance. Determine the class from the nearest neighbor list. So this is a way to find out the distance. Okay, and once you have the distance of each point, so let's say this is your training point. Okay, and we have, let's say, circles and then pluses. Okay, now we have it. We do not know what this point is, whether it's a circle or is a plus. So we calculate distance from each point just to know what is the nearest one, and then we take the majority count and find out whether it's a circle or a plus. Okay, so first is finding the distance, and how do you find it? Using Euclidean distance formula. So in the next step, take the majority vote. Okay, just take, let's say, k equal to 3 or 4. So within that subset, what is the majority? It's a circle or it's a plus. Based on that, take the majority vote. The one that is of majority is the one that would be associated with the new data point. All right, you can also weighting. Okay, you can also do a weighting without giving equal weight to each data point. You can also take the weight. So the weight factor, the weighting that you could actually take, is inversely proportional to the distance from the new data, and that's given by 1 by d square, where d is your distance, and that makes sense, right? The data point that is closest to the new data should be given more weight. Like in the previous example, here there are three training data points, right? There's a minus, this one, and this one, but this negative has a greater weight, or should have a greater weight, right, than these two positives, because they are farther from the data point x. So that's a better way of calculating a majority count. So how do you choose the value of k? So choosing the value of k is the key. If you choose the value of k to be very small, it is very sensitive to noise. Okay, because very unlikely you will get a very general view of something if you take just few data points. In any statistical estimation, you must be knowing that the number of observation, if it is less but it's very small, then you probably won't arrive at a very correct result. Okay, hence it is always preferred that you have more number of data points, or more number of training data points in the training samples. Similarly, if you have just two, similarly, in nearest neighbor as well, you should not have k to be very small. That's bad, and it's very sensitive to noise or outliers. If k is too large, the neighbor may include points from other classes. Okay, because if you take just too many outside points which are not at all related to your given data or the new data, it could include something totally unrelated, and that could bias the result. So the idea is to find an optimum, and you can try with multiple case that say for instance you are not very sure, start with 2, 3, 4, 5, and then you have a given test data, right? Not just one test data, I could have several of them. Do repeatedly with different k's, try out what number of k or what value of k is giving you the maximum accuracy in the test data. Okay, so what value of k is giving you the best accuracy? Okay, you try with 2, try with 3, try with 4, 5, whatever number of ways, because computational power has increased for computers, so we can just try out a number of values of k and run the algorithm that at what number of k your tests, the accuracy level in your test data is maximum. Just choose that k as your optimal k value. The one issue that you would be facing while building a KNN algorithm is the scaling issue, because you would be using different attributes, and attributes would be in different scales, or so attributes may have to be scaled to prevent distance measures from being dominated by one of the attributes. If you take the nominal numbers without taking into consideration, or without without taking into consideration the different scales, you'll be in trouble. Let's see this example. Here is a height which varies from 1.5 meter to 1.8 meters. That's in one unit. Weight is there in 90 lb to 300 lb. That's in another unit. And the income is from 10,000 to a million. So the numbers are different. Okay. So given the numbers are different, you will have a problem when you do not sort of normalize them or standardize them and use that in your prediction. That would give you some sort of dominance by one or a couple of attributes, and some of these attributes will not have any impact in your model or in estimation, and that would be a problem. So it is always good to sort of standardize and normalize. Another problem that you would be facing is the problem with Euclidean measure. If you do an Euclidean way of measuring the distance, you could have a problem, and that could possibly give you counterintuitive results. So here is this example. We have got two sets of data points. So this is binary data, this is another binary data. This is one binary data, and there's two sets of each pair of data sets. The distance, if you measure the distance in Euclidean distance for this pair, first pair, you get it's 1.142. If you measure for the second pair, you would get exactly the same value. But look at the distribution of data. In these two, in this pair, in the left one side, you see most of the data points are ones instead of 0, right? So when you match this to a new data point, you would conclude that the data point would be a 1, because the majority count is 1. Whereas here you would assume, or you would conclude that the data point would be 0, because the majority vote is 0. So the distance is same in both the sets, both the pairs, but the answer comes out to be different. So the answer could become counterintuitive sometimes. So using Euclidean distance is could be a problem in many areas. So what is the solution? The solution is to normalize the vector to unit length. Ensure that the length of the vector, the vector that you are measuring the distance, should be unit length. Okay, so when you normalize data, it would always be unit, right? It lies between 0 and 1, so it should be unit length. Alright, so that's pretty much about what is KNN classifier. You can compare your result with other classifier like Logistic classifier, with the support vector machines, with decision tree, and so on. This is not a very parametric way of estimating a model. This is more of just counting or just calculating distance, which is very deterministic rather, right? So you're not estimating parameters here. It's a non-parametric way of calculating things. So one of the good things with non-parametric way is that it is easy to do, but it takes high computational power. Okay. Whereas the parametric ways of doing like logistic regression is better in some sense, because it is something that can be understood well, and there are other aspects. For instance, finding out relationship between variables is something that you can find in logistic regression, not in KNN. So that's another difference between this parametric and non-parametric way of classifying your data. So that's about the k nearest neighbor classification algorithm. If you find this session very useful, please subscribe to our channels, and we'll be uploading more videos on various machine learning algorithms. Thanks.